So this is actually interesting that you said that you didn't use it in such advanced ways as I did. I use Jetpack navigation in sample code to like show what it looks like, but when we have the opportunity to like decide what tech stack to use, we use simple stack instead of Jetpack navigation, because in simple stack you don't have any of these problems, any of them.
Simple Stack, by the way, is the navigation library you wrote, just so people know what you're talking about. And I will put a link to this into the show notes as well. Yeah, this is what I was going to ask next. For you to talk a bit more about Simple Stack, and why do you think it's better than Jetpack navigation?
Yeah, there are quite a few reasons. Although better, like it's starting to offer a different feature set in a way, because Jetpack navigation with 2.4.0 started adding new things that like 2.3.0 really didn't have. Up to that point, like 2.3.0, we are basically offering the same set of functionality. With 2.4.0, they went a bit ahead and they have this save state, restore state parameter for multiple backstacks. I don't have something like that. There is a sample for how you would do multiple backstacks, but you would need multiple backstacks for it. It's not like one thing that works with magic and then you hope for the back behavior to be exactly what you want. Back on track as to what the key difference is. In simple stack, the way we use it anyway, and how it was intended to be used anyway, is that there are these classes that are called key classes. They define the screen that will be shown on the screen. This is abstract because it doesn't care if it's a view or a fragment or a composable. It really doesn't care. It cannot be an activity because activities don't share a context in any way. They are completely separate islands. So within an activity, you would be able to use this backstack class. And with that, you would be like, okay, so there's this new screen. What do I need to do to be able to render this new screen? And for that, Simple Stack offers some nice defaults, like the default fragment state changer, which assumes that you want to show fragments, like all your strings are fragments. And in that case, it ends up so that when you want to pass arguments to a class, like a fragment, I think, in this case, you have a parcelable data class. You annotate it with parcelize. You have all these properties. It just says, when this key exists and it's the topmost, so if this key is showing, then this is the fragment that has to be showing. That's basically all it says. And the way this works is that instantiate fragment equals fragment constructor. That's practically all you need to do, and the fragment will magically work. And for that, the way it's set up is that the fragment will receive this key class containing every parameter within this parcelable argument, this parcelable class, as an object that you can retrieve. So the way this works is that you get the key and everything is in it, like string, int, all that stuff. You don't need to care about any of it. You get it in a type safe way. You say backstack.goto key class, like for example detail key, and for example you pass it an ID, or the object, because it supports parcelable objects as well. It supports anything that parcelable supports, right? So you pass it in, and on the other side you just get this key with a function called getKey. You get it in a typed way. So this is the only thing you have to remember. Like if you want to show this fragment with, like, I don't know, detail key, then you have to say getKey type detail key, and you get it as this detail key. And any argument that's in this key will be readily available. You don't need to deserialize anything because parcelable already does that for you. So it's completely type safe. You don't need to type XML. You don't need to manage keys, string keys, have to manage it in such a way that it matches exactly what I needed in the XML and in the save state handle, which also needed the exact same string key as you defined in safeargs. None of that is happening in this case. There are no string keys involved. You just get the class typed with all the arguments that you sent. You don't need to think about it at all. It just works. So that's one thing. And I focused on this one primarily because we talked so much about argument passing because of navigation compose. I really do think that people should be mad about it, or at least they should not accept that you need to string concatenate just because the web does this. Like, this is a native Android app. We have a typed language. We should be able to use types when you're talking to a screen. Anyway, so simple stack. I did mention the safe state handle requiring the exact string key, right? Like, the thing that simple stack also does, I tend to say that Jetpack UModel or equivalent. And it's because simple stack allows you to define that if this key exists, then I want this model class that I call scoped services to exist. So that means that you call this constructor, you say that when this screen is showing, I expect this to be there. And this is how you create it. So if you check for sample code, it makes much more sense than the way I'm talking about it, because for me, I see it in front of me because I wrote it a while ago. But
where can people find that sample code on your GitHub?
On my GitHub, yes. I think I will just give you some links.
Yeah,
and
I will put them all into the description.
Yeah, just to have one for compose and for fragments, because the one that I really like as a sample is called the FTUE sample, the first time user experience sample.
You also have a YouTube video where you give a presentation and explain all these details, right?
Yes, there's a full talk about it. There's a talk about it, explaining it with multi-activity, fragments, multi-activity, Jetpack navigation, and fragments back in the day.
I will link that as well.
And simple stack, of course. And with simple stack, I show that just how simple it can be. But what matters here, though, is that so you have these scope services, and it can receive the key as an argument as it is created, right? So the reason why this is important to us is that there's no safe state handle where I have to remember the string key to get the right argument from a map. I just get the argument. It's that simple. So what you end up doing here is that you can use the key to get the initial parameters into your live data and stuff. And unlike safe state handle.get live data, you have to type a bit more code, because get live data internally saves stuff and restores stuff for you. Well, in the case of simple stack, you implement this interface called bundleable, and you return a bundle, a state bundle, but it's practically a bundle. You return a bundle with all the stuff in it, and then you restore it. And the restoration would be manual in this regard. It's not like safe state handle get live data, which tries to save it for you and you hope for the best. And if it didn't work, then you have to set a safe state provider. In this case, you do any conversion into bundle and you restore it in from bundle. And this is where I've had someone ask me once, so does that mean that you save and restore every parameter like a peasant? And I was like, yes, because I control it. I can actually define this object to be a byte array if I needed to, instead of having to like set a safe state provider, which I haven't really seen anyone use, even though you sometimes need it. Yeah, so that's a thing. So the scoped services match the lifecycle of view models. They are basically the same thing. And you even have something like viewModel.onCleared. It's called onServiceUnregistered. It's a completely optional callback. Something that's a major benefit in simple stack in this regard. There are two major benefits here compared to view models. One of them is that all of these callbacks are optional. Like you implement the interface and then simple stack will call it. And you don't need to extend from view model because it's expected that you have onCleared always, even though you don't need it. And then you inherit this bag of internal objects that they use to create view model scope and stuff. You don't have that because you just have a class. You just create a class and that's what it is. There's no magic. You literally don't have any structural constraints imposed upon you. It's just a model class that will exist across config changes. You don't need to care about this at all. And the other primary benefit that Jetpack UModel will never be able to do, it's not even able to do it with Hilt, is what I call scope inheritance, which means that in the case of simple stack, there are two scoping mechanisms. The talk explains it. There's implicit scopes and explicit scopes. Explicit scope was written later because we needed it, and then we realized that this is actually a really good idea. So the way it works is that you can define that this screen has an associated scope, and this scope exists if this screen is in the backstack, right? But what if there's a flow where you have 4 steps and some of them are optional, right? So in that case, one of these will be missing, and you're like, hey, hold on a second, we didn't take that into account. We expected this to be here, but it's not. So in that case, we have explicit parent scopes, as I call it. This is the other scoping mechanism, which says that if any of these screens exist in the backstack, then the shared parent scope of theirs will be created for them if any of them exist in the backstack. And this allows you to create some really nice stuff. This basically means that you have a flow of 5 steps, for example. If any of them exists, then this is kept alive for you. Its state is managed for you, like persist and restore, like across process that. And you don't need to think about it. In this case, you have to only think about how they need to return the same string tag to say that this is the scope that needs to exist. But I found that returning the fully qualified name of the object that you expect to be created in this shape and form, that is technically completely reasonable. Like, that doesn't change it. It's shared. So, and one time I did it in such a way that I defined an interface. Each of them inherited this interface. It said that, I don't know, let's say edit profile flow key. That was the interface name, and what it just defined is that it expects the shared model to exist. And then the shared model exists between these 4 screens. And this is basically what you do with nested nav graphs and nav graph scoped view models in Jetpack navigation. But the reason why this is interesting in the case of simple stack is that if a screen has its own scope, then it can just say, look up this shared model and then have a reference to it at construction time. And then you can directly talk to the parent scope. Like, you can talk to the shared model from a view model. So you can encapsulate view models in another view model that are within a shared parent scope. This concept does not exist in Hilt. It does not exist in Hilt at all. And with Jetpack view model, you can only do it if you have inline factories and you create one of them and you pass in the other one to the inline factory, and nobody does that. Nobody does.
What does scope mean in this regard? It means a place where you can instantiate your view model and keep it alive.
Practically, yes. That's basically what it is. Like, view model itself, it really just represents the scope that is bound to a screen and is kept alive across configuration changes. And this is the same concept. So if you want to go into the nitty-gritty details, as they call them, it's basically a map string any. Like, that's what it is. That's what the scope really is internally. And you can put anything there, like, because you have... okay, so you say add and you give it this object, and the default string tag that is used is the fully qualified name. So as such, within this, you can add it that way, you can look it up that way, and if it exists anywhere in the scope tree, you can find it. Where was I going with this? So the scope really is just a way to store your objects and make it managed by simple stack, so that you get these callbacks. The bundleable, which I mentioned, which means that any of these scoped services, as I call them, but they are kind of like view models really, so that any of them can save their own state. You can implement scoped services registered, which tracks that this thing was created and this thing was destroyed. This is what I said is similar to onCleared. And there's also activated, which is that this is part of the scope chain that is the topmost, so the one that is currently showing. And one that I'm kind of proud of, but it kind of breaks with Compose's back handler because, I don't know, backpress dispatcher is a nightmare. Is scope services handles back. So what you were able to define is that in your view model you want to intercept backpresses, and you can return a boolean as to return true if you did handle it, return false if you didn't handle it. So what people used to struggle with is, how do I make it so that my view model is the thing that triggers whether I intercept it back and just modify something in my state that is rendered on the screen, instead of having to go through the fragment to do it and then pass it to the view model, and then the view model processes back and then tells the fragment if it did something, and then suddenly you realize that with backpress dispatchers, you cannot actually do this because you have to know ahead of time if you want to handle backs or not. And this is why I really don't like backpress dispatcher. I think it's not a good API. But what's important here is that your view model can intercept back. You don't need to go to the fragment to do it. You can do anything with that. And this, as I said, it goes through the scope chain. So that means that either the screens or any shared explicit parents that exist, if any of them are handles back, then it's asked, hey, do you want to handle this? And they're like, nope. And then it goes up. And so you can intercept back at any level. And that's really useful, actually.
That's another benefit of simple stack over navigation library.
And view model. Because this is practically a replacement of view model in a sense. This is why when people talk about it, I'm like, I use something equivalent but not view model. This is why. Because, and there's one major benefit, of course. Because I did tell you that you don't need to like extend or inherit from anything. You just create a totally normal Pojo class. The reason why this is important is that the view model factory, it expects a class that is a subclass of view model, and then it returns something, right? That's how it works. But as such, you cannot say that I want a view model that implements this interface, and then you never see the exact type of the view model. You cannot swap that out. You are forced to see the exact type of the view model. And as such, you cannot have a separation where you would be like, my view expects the implementation of an interface that is implemented by this view model and then not see the view model itself. You cannot swap that out. But with simple stack, you can definitely say that I added this model class and I also bound it. I added this alias for it, as the internals say. So I bound it as an interface so that when it's looked up as this interface, then it will be found as this interface. And then the view actually has no idea who the view model is or where it's coming from. The only thing it knows is that I have an interface that I defined, that someone can handle my actions and someone can give me data. And if you think about it that way, that's very composed-like, isn't it? That you get these arguments through an interface, but you don't know the exact type. You don't see the view model. And in a way, I feel like this is why people are still passing view model in so deep into the composable hierarchy, because they are not used to this ability of being to separate your view model from your fragment. Yeah, so as such, what it really did offer is seamless type-safe navigation. You literally just say backstack go to something and it just goes there. It works immediately. You never run into issues. You had these scoped services that are super powerful. They have safe state persistence at any level without something like a safe state handle. So you don't need to micromanage string keys that are defined elsewhere. You do need to use string keys when you want to save into the bundle and restore from the bundle, but that's local to this class, so you don't mess it up. You can't mess it up. You can't have it like someone in the navigation file changed this string and now I get nulls in my code. That doesn't happen at all. That's impossible. You also get these really nice callbacks to define whether this thing exists or not. You get this backhandling in a view model. You can actually get the backstack reference in a view model. So instead of what you did originally with how you would channel down your events from the view model into the fragment or the composable with the disposable effect and then pass it to the nav controller, you just see the backstack directly in the view model and you can call functions on it and it just works. You don't need to... Simple stack already handles that the view is being recreated in the background and should only show the new view when the new view is available after a config change. This is all handled for you. You don't need to care about it. You just call the function in the view model and it navigates for you. Imagine that, because that's something that people, I think, forgot about. Like, remember how you had this live data of event T of navigate to detail screen, and then you set it on the live data, and then you use this event observer in the fragment. None of that is needed. You just call one function.
I'm actually still doing that, not with the live data event wrapper, but with flows, with a channel.
Yeah, and then you would need the disposable effect and channel in this case, yes, and you collect the flow in the composable so that
Launched
you actually
effect,
have a
I
reference
think.
to the
Launch effect, because we need a coroutine. Yeah, doesn't matter.
same thing as remember coroutine scope and using a disposable effect and using launch, which is what I tend to do. This is something I asked on Discord, the Android Dev Discord. Am I the only one who does this? And they're like, yes. And I'm like, okay. And it makes perfect sense. Theoretically, this is what launch defect does internally. But yeah, so you collect this channel in a launch defect, and then you have a reference to the nav controller, and then you navigate. But what you really wanted to do is just
navigate from the view model.
Navigate from the view model. And with simple stack, you get the backstack, and you just call the function, and you navigate it. You don't need to do any channel, any effect, anything at all. It just works. So that's also a benefit.
Yeah, this was a summary of simple stack again, right? And
yes,
I think you didn't mention the scopes in your summary. I think
I didn't. Oh yeah,
maybe
yeah, like these scoped services, these view models that I mentioned as view models, they technically, and that you can easy, like you just return this string key and you end up with this shared model between screens, but subscope compared to like the activity, but it's a super scope to fragments. So it's like this scope in between the screens. And this is something that people wanted to solve for a very long time. Navigation, like nested navigation and navigation graphs are technically one solution. This one is another. But in this case, in my case, you can inherit from the parent scope and talk to the parent scope without having to, like, I don't even know how you would do it with fragments, to be honest. You would just see both of them, maybe? I'm not sure. Like, they can directly talk to each other. The child can talk to the parent. And this way, you can actually destructure view models. You don't end up with this one that's like 500, because you can pass a view model to a view model. This is a thing you can do with simple stack.
Wait, so I can talk from a smaller scope view model to a larger one?
Yes. Yes.
Because this was a problem I had, that this wasn't really possible. And then what
with
I
simple
ended
stack,
up,
this is immediately supported.
what I ended up doing
do
was usually going over application scoped singleton or something like that. Or maybe not application scoped, but through a singleton that's behind the view model, basically. I tried to come up with an example where I wanted to talk from a smaller view model to a larger one. But with the normal navigation library, it's not possible, right? So I use a singleton.
It happens if you have a multi-screen flow. That's when it happens. Like if you have like this flow that takes like 4 different screens, and on like one of them you have you have this search and stuff, but you still need to mutate some user input in a shared state, but you want to discard it if you navigate away, like you cancel this flow entirely, then you just don't want to have it in a singleton. What you can do if you want to survive across forced-up and attributes, of course, is save everything to a database or data store or shared pref if you really don't like yourself. But you don't always need that.
Yeah, I think in my example, I was actually trying to talk from a smaller view model to an activity scoped view model. This is why I ended up with a application scoped singleton, because that's the lifecycle of the activity in a single activity app, right?
Yep. Funny thing, actually, with simple stack, there's the concept of global services, which is like the parent scope of all services, and it matches the same scope as the activity scoped view models. And you can talk to them with just saying lookup when you create the view model for the screen, and you get a reference to it, and you can just talk to it. Imagine that. You can actually just call a function and you get the reference, and it just works. You don't need to care about it because it just works. This is something you can do, and it's easy.
Yeah, nice. So people should check out SimpleStack. And I don't know if I missed that, but does it work with Compose or only with fragments?
Oh, I didn't. Well, I did mention that Backstack, the code itself, like SimpleStack's core as it is, it doesn't know about any of it. Like the only thing it knows about that's Android specific is parcelable. Like that's the only thing it really cares about. Like it has code to support view-based navigation. I haven't used that in a while, but that's there. But you will probably not use that. The way it works is that you have these key classes that I mentioned earlier that contain all the arguments and describe what screen should be showing. And how that is shown is totally up to you, which means that I offer defaults for how I typically use fragments and have been using fragments for the last 5 years. And on the other hand, there's also another repository called Simple Stack Compose Integration, which I consider to be slightly experimental, but not as experimental as Navigation Compose, which is able to render composables for you as the building blocks of the app. Like no fragments involved, just composables, switching between them. And it actually has a slide animation by default. Like if you go forward, then it slides in. If you go back, then it slides out, which is fascinating because how long has it been that Navigation Compose didn't support that? 8 months, I think? I had this working 8 months ago, guys. This was actually working 8 months ago. So on the other hand, they had to rewrite the entire internals of Jetpack navigation to support the idea that navigation is not just a command that you execute once and then something will handle it, but they actually need to track that the state exists and there's an in-progress state while two things exist at the same time, and one of them has to be rendered as it is navigated out, and that ends and it's an asynchronous process. The backstack in Simple Stack was already assuming that it's something that is an in-progress process that will be executed eventually. It's generally hidden from you because the default fragment version, it uses a synchronous call. I mean, synchronous call, not asynchronous call. And but with Compose, this was super easy. For Jetpack navigation, they had to rework the internals. and it's actually fascinating because that's something that's been happening like in the past 2 months, I think, maybe more. Because without that, you cannot navigate between two composables and animate their changes. They have to both exist at the same time. And you need to track that one of them stopped existing. Anyway, so back on track. Yes, there is a Simple Stack Compose integration. And something that someone asked is, am I making a composified version of Simple Stack? Which would mean that Simple Stack would be purely Compose only and would only support Compose, but still have all the things the Simple Stack does. And this was not a priority for me. And it was not a priority for me because as we use Compose, I primarily consider it a rendering framework. Like I know that you can store state in it. It has the saver framework. You can use remember savable. You can manage anything. And if there was a backstack that was like a composable backstack, for example, then you would be able to nest them indefinitely. But my problem with that approach, and the reason why I'm not doing this, is because once you have 3 levels of nesting with these backstacks, then which one do you want to talk to? How do you know which one you care about, right? Like currently there's one backstack and it manages the top level scopes, and it's basically exactly how Jetpack navigation works as well. They also have one nav controller, as you know, in the nav host fragment. And while you were able to nest them, you typically didn't, because then the which nav controller owns what scope, and those nav controllers definitely won't know about each other and ask the parent, hey parent nav controller, do you have this scope, because I have no idea. They don't have inheritance. For me, I would have to ask the parent, and then I have to define what does it mean to be a child backstack and all that. And it's all possible, but I haven't found it to be necessary. And as such, I don't really see a reason to like connect Simple Stack's internals to be based on Compose, because it doesn't really offer me much. I just need to navigate from one screen to the other and render the changes. And as long as that's what I need, one global backstack works pretty well.